Hello everyone, welcome to new chapter. Center of mass. Have work power energy is over that है center of mass and collisions. Collision to center of mass है ना. NCERT हो फिर होचन. NCERT को system of particles chapter आखो नम्बे तो system of particles. Rotational motion to center of mass हो है ना combine नम्बे तो. So we will do that chapter here. Mas apena center of mass video na. Aban banai video. See, what is a center of mass? Center of mass cho piha. Definition cha jong zom lo na hi wanga cho ga sim de tia la chun. Center of mass is a point where the entire mass, okay, object ha chuna. So the entire mass, so the point where the entire mass of the object appears to act. Okay, simple ta sai nga chuna. Or you can say the the point where the entire mass of the object or the system can be considered to be concentrated. Okay. But here heading suppose I have a rod. Okay, so let's say I have a rod here. Hichi rod pa hai na. Hichi rod pa hai balance ball de tilauchun. So how will you balance with your finger? Okay, let's say you try to balance this. So how will you balance this one? So this is possible if you put your finger here. Na ita hai. Okay, ita hai. So there is a chance, na. So there is a chance. So if this side has equal length L, this side has equal length L. So if you try to put your finger in the middle, so here there is a chance of balancing the rod, na. So here you can see that though it looks like the entire mass of the rod is concentrated in the middle. Okay, here. Rod QC hello example dang khatsu batang. Disc disc. Suppose you have a disc. So here, if you try to balance this disc, okay, balance body dilation balance so it is possible if you try to balance it in the middle. Okay, so it looks like that the whole mass is concentrated at the center. Okay. So if you try to rotate a book with your finger, so you have to put your finger at the center of the book and then rotate it, right? So see, it's a few examples I'm giving you. Center of mass is simple. It is the point where the entire mass of the object appears to act, or you can say appears to be concentrated, right? Masapena so system of particles are center of mass holder in videos. Okay, let's see. Center of mass holder thing na. So you have a general formula. So center of mass position. Okay, position of any center of mass will be given by so x com I cap plus y com j cap plus z com k cap. Okay, as it's a 3D space na. 3D space center of mass position is eating wala chun x khat ngai y khat ngai bala z ngai so na x comma y comma z ya. So here x by so this is given by this formula. X com so m1 x1 m2 x2 m3 x3. So this is the number of particles that you have. For example, particle thum question asam kido alachun m1 m2 m3 chan mo naman na. Particle li kipi alachun m1 m2 m3 m4 chan na chi na. Okay, like that. So the x here the x component will be given by this formula. Similarly, y component will be given by this formula. Okay, z component like this. Formula pa hai na. So it is the same everything. Okay, so m1 x1 m2 x2 like that na. The important thing is how do you use this? Okay, how do you use this formula? So we will look those things. Okay, question nearly to me solved you. So then it will be clear. Okay. Right, so let's see. I'll give you one example. Suppose I have xy xy plane ako. So I have one particle here at the origin. Okay, origin so comma beta coordinate so 0, 0, 0 so na origin so ale particle na kani. Suppose I have here x axis is at so let's say 4, 0, 0 na x axis so ale khatola bile na particle khato chipahi. Let's say 3, 4, 2 tilde. Okay, like any quartet na. So A, B, C tilde. Particle thum so ale mo center of mass hoila yam de ha. Azo formula thum ho na he cho it apply di ham convert sagon ni cha. Atile ama sapena chu tang position of center of mass pe ha RCOM chichu XCOM I cap na plus YCOM Z cap plus ZCOM K cap kiti chula na chila he formula cho atile ma sapena XCOM cho holo te chila he XCOM holding achu hilai particle is out of ma thumum jina chila he so then therefore I have to go M1x1 plus M2x2 plus M3x3 divided by M1 plus M2 plus M3 chula na ja formula cho okay hodele ma jong pi te question ahe suppose let's say 1 kg na so let's say 2 kg okay and then 3 kg tiu atile M1 1 to 3 hoi ga kha ga mo assume le jon A pa he 1 tiu ten B pa he 2 C pa he 3 na example atile formula to M1x1 plus M2x2 plus M3x3 divided by M1 plus M2 plus M3 chi formula cho ala chala hin value put leo chun pia M1 he pia 1 kg na ke pi 1 into x1 cho pia x1 see in this formula okay he chala x1 pa he pia so what is this? This is the center of mass of okay position of center of mass of M1 okay Hechila he point mass ila ucho chila he point mass kila ja chu point mass center of mass of point it is the point itself right if you have rigid body zolang phale rigid body continuous body in both phale chun chipen hi mandiu na so the meaning of x1 so here x1 is the position of M1 okay so basically for a particle atele M1 chu hilayam ha M1 chu so here you see x component 0 right so here M1 into 0 plus M2 chu zan ham 2 kg okay into x2 chu biha so x2 is this one okay see when you write okay so this is your x1 this is your y1 this is z1 okay chipa hi x2 comma y2 to z2 na ji abana mass 3 na pa hi ji x3 hong ding ji y3 hong ding chipen hi z3 hong de so here 2 into x2 chu pi ham 4 na plus m3 chu 3 into x3 chu zat ham 3 so divided by m1 plus m2 plus m3 is that hong ko de ha hi so 4 2 are 8 plus 3 3 are 9 divided by 6 so 8 or 16 17 by 6 okay x component pa chu na ala chita banga hi so same way you find out the y component of pdm mass thomom na so you have to go till m3 okay m1 y1 plus m2 y2 plus m3 y3 okay divided by m1 plus m2 plus m3 tayo na ala m1 so piham 1 kg na 1 kg into y1 ko piham so y1 is 0 okay y2 is 0 and y3 is 4 right so m1 into y1 is 0 plus m2 into y2 zong 0 plus m3 2 into 3 3 into y3 2 4 okay divided by m1 plus m2 plus m3 nah is that 3 4 are 12 divided by 6 which is 2 okay y component is 2 ta na so similarly you find out the z component ZCOM is that the has m1 z1 plus m2 z2 plus m3 z3 so divided by m1 plus m2 plus m3 na chala hi m1 to 1 is a z1 to zata z1 to 0 z2 zong 0 z3 khu 2 so 0 plus m2 into 0 plus m3 into 2 na divided by 1 plus 2 plus 3 okay z3 to 2 in ham na so 2 okay atila chila hi zan podo di ham so this is 3 2 or 6 divided by 6 that is 1 okay so finally what is the RCOM position of center of mass usar ham XCOM I cap XCOM to 17 by 6 na 17 by 6 I cap plus YCOM to 2 Z cap plus 1 K cap so this is your center of mass it's a evaluation RCOM bar to position vector so position vector to with any coordinate point okay can be written as a vector na position vector so here I can also write so position of center of mass okay RCOM so this is what so 17 by 6 comma 2 comma 1 okay position of center of mass so next we'll try to solve some questions na masabena chu 3 particles mass 1 kg 2 kg 3 kg are placed at corners of ABC equilateral triangle ABC okay edge is 1m so locate the center of mass of the system Hichi formula apply na dinga chuna. Hichi formula apply na dinga chu BP ngai cha ha. So x1, x2, y1, y2 ho ngai cha chula na. So which means the position of those particles are important. Okay. So that is why whatever is given, okay, you have an equilateral triangle here. So whatever is given, you try to put this in an xy coordinate plane. Okay, as it's coordinate is x comma y. So here, if you put this in the coordinate axis, so here xy like this. Okay, so this is x, this is y, and then you have to write the position of this chart masses. Okay, let's say I have 1 kg here, 1 kg chalayama, so 2 kg is here. Okay, and then 3 kg is here. Sides is KPM 1 meter na, so 1 meter is given, so all the sides are 1 meter. Atile coordinate point 0 na, 1 kg pa hezat ham 0,0. Okay. Chila hi zg ngai lo na, xy see triangle is a plane. Okay, so in xy plane, so coordinate pa hi x, y both na ji theu so chila hi. So here tang side to 1 meter hi ala chun 2 hi zat na ha, 2 will be at 1,0. Okay. Abana 3 na pa hai zat diham, 3 na pa hi, so it will be at 1 by 2, comma root 3 into 1 by 2. Okay. Hichi height pa hai na, height of equilateral triangle chupi ha, root 3 into sides divided by 2 chula na. Sides to 1 here lechun root 3 by 2. Okay, this is the height, the y component. Abana x lang pa hai pi ha, chipen hi 1 here lechun. Hichi half pa hai na, hichi half pa pi ha, so this is 1 by 2. Okay. Ati lesson chahi coordinate point si mo na. So now you have what? You have x1, y1. Okay, you have x2, y2. And then you have x3, y3. Okay. So let's find out the center of mass. Mass apena to xcom. Mass is mass thom taom na. So you have to go till m1 x1 plus m2 x2 plus m3 x3. Okay. Divided by m1 plus m2 plus m3. Okay, like this. Okay, so direct value can put this as a formula m1 is ham. So you take this is 1, this is 2, this is 3. Okay, m1 who is at ham 1 na, x1 who 0 plus m2 to 2, x2 to 1 plus m3 to 3, x3 to 1 by 2. So divided by m1 plus m2 plus m3. So 2 plus 3 by 2. 2 are 4, 5, 6, 7 by 2. So divided by 6. Okay, so this is 7 by 12. Okay. Chita pangachu YCOM zong hol lechun YCOM piha m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. M1 to 1 into y1 to 0. Okay, m2 to 2 into y1 zong 0 na. Hichipahi y1, hichipahi y2, hichipahi y3. Okay. So plus 3 into y3 who is at ham root 3 by 2. So divided by 1 plus 2 plus 3. To solve this in that ham, so 3 root 3 divided by 2 divided by 6. Okay. To that ham, so 3 root 3 divided by 6 2 are 12. So 3 1 is 3, 3 4 are 12. Kutila YCOM2 root 3 by 4. Nah. Chita pangacho ZCOM zang hol lechun ZCOM to that ha. So M1 into hichila he Z talaw na. So all the Z are 0, so ZCOM is 0. Okay. X to Y bow 0 lechun na. Atile center of mass hoy lai ha. Coordinate to 7 by 12, comma root 3 by 4. Okay. Coordinate point acho na, position acho. Ala vector acho iti ha. So RCOM will be equals to 7 by 12 I cap plus root 3 by 4 z cap. Okay. Question abang lakon na component ando 0 na. So x component, y component. So you like this. Okay. So here also, see this is the x component, right? So this is the y component. Next you have 3 particles ke bang mama na. So chala here 0.5 1 kg to 1.5 kg hisa. Right triangle maintain sides to 3 4 5 kpa. Locate the center of mass. Batang formula thomo chu apply na ding achu x1 y1 z1 to x2 y2 z2 ho ngai cha cholat na. So that means the position is important. Okay. Khutile chala hi, so first thing put in the xy plane. Xy plane put lechun. So this is x, so this is y. Atila 0.05 pa hi origin na omna chala hi. So here this is at 0,0. let's say mass 1 okay until khat pa he mass 2 tiute 1 kg pa he khutile 1 kg pa coordinate he zat ha 4,0 na aji chu 0.5 to he chi zat ha chi pen hi 4 ki pi chula na jela he so therefore 2 pa hi 4,0 amding abana 1.5 pa he zat amde ha so 1.5 pa hi so it will be 0,3 na aji chu chilang hi zat ha chilang hi 3 chula y he na okay so now we have everything coordinate okay has kyota ke ta na so this is x1 y1 okay so here x2 y2 abana pa hi x3 y3 direct in formula put jung ta so xcom sa ham m1 to 1 0.5 na sila 0.5 into y1 to x1 to 0 plus m2 to 1 kg x2 to 4 okay plus m3 to 1.5 kg into x3 to 0 right so by 0.5 plus 1 plus 1.5 is that the so 1 into 4 to 4 so 3 na jela he so 0.5 plus 1.5 to 2 is a 2 plus 1 to 3 abana so ycom sa diham ycom to m1 into y1 0 na plus m2 to 1 y2 zong 0 nalai plus m3 to 1.5 into y3 to 3 so divided by 0.5 plus 1 plus 1.5 okay is that the so 1.5 into 3 to 4.5 divided by 3 na so 3 1 is 3 3 5 are 15 okay so 1.5 so therefore center of mass is at ham coordinate as dinga cho 4 by 3 comma 1.5 ipya 3 by 2 tin so so 3 by 2 okay or position vector as it in ha so rcom equals to x2 4 by 3 I cap okay plus 3 by 2 z cap okay this is the position abana 4 particles a b c d having mass m2 m3 m4 m are placed at the corners of a square to a square kipita na so I have a square so put in the xy plane okay like this square to chalai humding na mass to m okay so 2m 3m to 4m na side to pm side to a na chalai side is a atile mass apena so position jingai na coordinate to mass m to hilai mam 0,0 okay 2m pa khola le so side to a hele chun 2a to a, 0 am dena abana 3 khola le a, a okay 4 khu 0, a okay aji chalai a hi jana chi chu chalai a oma chalai jong a hi ja chu chalai a na so here is a, a okay then what is xcom x component of center mass so m1 into 2 I have the mass lita amjala so you have to go till m4 okay m1 x1 m2 x2 m3 x3 m4 x4 atila chun chala hi chipa hi x1 y1 na hi chipa hi x2 y2 x3 y3 x4 y4 okay 1 2 3 4 atile xcom to m1 to m na x1 khu 0 okay plus m2 to 2m x2 to a okay plus m3 to 3m x3 to a plus m4 to 4m x4 who 0 na divided by what is this m plus 2m plus 3m plus 4m is that ang po diha solve lesson so you have 2ma plus 3ma so that 5ma na so 3 7 8 9 10 okay so I will have here 5ma divided by 10m so mm gets cancelled out 5 1 is 5 5 2 are 10 so that a by 2 okay atila similarly ycom jong hol lejon ycom so that ham so m1 into y1 ko 0 na plus m2 to 2m into y2 to 0 plus m3 to 3m y3 to a plus m4 to 4m into y4 to a okay divided by so m plus m2 plus m3 plus m4 solve lessons are put them so see here I have a 3ma plus 4ma to 7ma na right so I have a 7ma divided by 10m okay mm gets cancelled out you have 7a divided by 10 right Atile finally, what is the position of center of mass? Center of mass position to a divided by 2, 7a divided by 10. Okay. Ahilole in terms of vector to RCOM to that RCOM to a by 2, I cap plus 7 by 10, 7a by 10, z cap. Okay. So this is the center of mass. Okay. Next one more on center of mass. The position vector of three particles m1, m2, m3 are given. See, instead of giving you coordinate, they give you in terms of vector. So that means m1 to 1 kg na 1 kg per position hi piha. So r1 vector is given as I plus 4j plus k. So position will be 1, 4, 1 tine cho Japan here. Okay, similarly, m2 to z kpm, m2 to 2 kg na Japan here. So what is r2? So you look at this r2. So 1 I cap, 1 j cap, 1 k cap. Okay, that means this is at 1, 1, 1. Okay, m2 pa na. Abana m3 to biham m3 to. So here if you look m3, you have 2, minus 1 and minus 2. Okay, so 2, minus 1, minus 2. So this is x1, this is y1, this is z1. So x2, y2, z2, x3, y3, z3. Okay, so here m3 is 3 kg na. So m3 is 3 kg. So the position is 2, minus 1, minus 2. Okay. Until the formula so apply legend sizing na xcom to pm. So mass thom so m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3 na. Until m1 so 1 hisa x1 khuzat ham 1 kipi na question our plus m2 so 2 x2 khu piha 1 na plus m3 so 3 x3 khu 2. So divided by m1 plus m2 plus m3. Is that the so 1 plus 3 2 are 6, 9 na 6, 7, 8, 9. So 9 divided by 6. So which is 3 by 2. Okay. Next YCOM. Y to piha m1 to 1, y1 who 4. Okay, plus x2 to 2, y2 who piham 1 plus m3 to 3, y3 who minus 1. Okay, divided by m1 plus m2 plus m3. Is that the ham Japan here? So 4 plus 2 to 6, 6 minus 3 to 3 divided by 6. So which is 1 by 2. Okay. So similarly, ZCOM zong ho leojun. ZCOM to piha m1 into z1 who is that 1 na plus m2 into z2 who 1, m3 into z3 who minus 2. So divided by m1 plus m2 plus m3. Is that the here? So 1 plus 2 to 3, 3 minus 6 to minus 3 divided by 6. So this is minus 1 by 2. Okay, 3 1 is 3, 3 2 are 6. At the left position, so now finally, what is the position of center of mass? Center of mass is located at 3 by 2, 1 by 2, minus 1 by 2. Okay, so this is the position of center of mass. Na, the position vector so RCOM will be 3 by 2 I cap plus 1 by 2 z cap minus 1 by 2 k cap. Okay, so this is your answer. Atile banana two particle system. Suppose azawai bol hoche velajun particle ni niom thomom na jongoma lium na jongom jolana. Atile suppose you have only two particle. Okay, particle ni bosi om diute. So here let's say I have two particles. So one particle is at the origin, chipahi m1 Newton. Another particle is at here. Okay, so chipan hi x is chipan hi y na. Until origin pa chu vedang adni na separation pa hi r tu to asi. So the separation between m1 and m2 is r. Okay, that means position chu ppd ha m1 pa hi origin amala chun 0, 0 na. M2 pa hi distance r amala chun r, 0. Okay. Atila chila hina formula ho chamang leo chun masapena chu xcom chun na holote. So what will be the x component of center of mass? m1 into x1 to pm 0 na plus m2 into x2 to pm r. Okay, so divided by m1 plus m2. Okay, so this is m2 into r divided by m1 plus m2. Okay, chichupite na ha. So see, chila hi value chun m1 to m2 hi x axis sam chula na chila hi. So that means the y component of center of mass will be 0. Okay, as it y1 zong 0, y2 zong 0 chula na. So here I'm going to say do something here. Suppose center of mass chila yam diu chila hi. Suppose center of mass is here. Okay, let's say this center of mass is at a distance of r1 from m1 and it is at a distance of r2 from m2. Okay, center of mass pa chuna. Atile chun chila hi beta YCOM 정수 0 해자죠. center of mass position 주 비디하. So XCOM, YCOM 저러나 position as eating alachun, coordinate as eating alachun. So therefore this is M2 into R, M1 plus M2, 0. Okay, Y component is 0. Chuchu bitina ha. So see, if I say 4, 0, okay, so that means this position is 4 unit distance from the origin. Okay, hilahi r, 0 ti para chun bitina ha. Origin apara hi r distance agam hatin juna jalahi. Kotile m2 into r divided by m1 plus m2, 0 ti chun, which is center of mass pa hai na. From the origin, it is at the distance of m2 into r divided by m1 plus m2. Okay. So that means this is the value of R1. Okay, R1 paso na. So therefore, R1 is equals to M2 into R divided by M1 plus M2. Okay, equation number 1 tip. R2 pa hoiti na holo dio ha. So how will we find this R2? Total distance ki he chula na chipen hi. This is R and I know the value of R1. So what will be the R2? R2 will be R minus R1. Okay, R apa R1 minus bola na. So therefore R2 will be equals to R minus R1. So which means R minus M2 into R divided by M1 plus M2. Kote let's solve the you will have M1 into R divided by M1 plus M2. Okay, so this is R2. Chi khat chi ni na. So see, R1 is equals to M2 into R divided by M1 plus M2. Abana R2 to PM R2 to M1 into R divided by M1 plus M2. Yeah. Atile chun, see, the center of mass is at a distance of this from M1. Okay. And it is at a distance of M1 into R by M1 plus 2 from M2. Right? But the question now, how far is the center of mass from this? Okay, example, so 1 kg to 2 kg kpia. So how far is the center of mass from 1 kg? That's a question ke tong thai cho two particle system ana. This is a medical example yung acho the two particle system kete by syllabus asong kg cho. So two particle system ta kg na. So therefore you have to remember these things. Abala chun na. So here jilai para value chun. So here if I transfer this M2 here, okay, downwards. And if I transfer this M1 downwards, right hand side I puma. So R divided by M1 plus M2, R divided by M1 plus M2 chura na. So if the right hand side are equal, left hand side should be equal. Kasi na piha. So you bring M2, M2 hi chila ko ita. So what will you have? So R1 divided by M2 should be equals to R divided by M1 plus M2. Na. Similarly, second equation now M1 pa hing kai su leo chun. So I will have R2 divided by M1 should be equals to R divided by M1 plus M2. Atila chite ni value chun z lang ai pipima R by M1 plus M2, R by M1 plus M2 chula na. Z lang ke ba la chun value zong ke ba ngai chula na. So you equate the left hand side. So I will have here R1 divided by M2 should be equals to R2 divided by M1. Okay, or cross multiply bola chun M1 into R1 should be equals to M2 into R2. Okay. So you have another relation. Mass nito akika distance relation pa hai na. So in some questions it may be helpful. Okay. So remember this one na. So R1 is equals to M2 into R divided by M1 plus M2. R2 is M1 into R divided by M1 plus M2. Question khali ni ga bolo ta chala hai. So let's say I have 1 kg. Okay, 1 kg. And I have another is 2 kg. Okay. Kutile chila hi separation to let's say 10 centimeter na 10 centimeter to Kutile center of mass na. How far is the center of mass? How far is the COM from 1 kg? Okay, 1 kg apa na chana gamlham. So hichipahi M1 hiya hichipahi M2 hi lechun bata center of mass example chala hi center of mass amala chun hichi hi R1 na chipen hi R1 chipen hi R2 dinai cho Kutil question jon pido ha. Question jon R1 do chala na chala hi. So how far is from 1 kg till R1 do so. So therefore R1 is equals to pida M2 into R divided by M1 plus M2. Direct I apply to. So how much is this? M2 to 2 kg, R to separation to 10 centimeter divided by 1 plus 2. Okay, M1 plus M2. So this is 20 by 3 centimeter. Okay, right? Same way, if I ask you how far is the center of mass from 2 kg, R2 so R2 will be equals to M1 into R divided by M1 plus M2. Okay, sila 2 malachun, sila 1 na. Sila 1 malachun, sila 2 Okay, so how much is this? M1 to 1 kg into separation 10 na divided by M1 plus M2. So this is 10 divided by 3. Okay, check na din R1 plus R2 to biham 10 chula na. You can also check here, okay? R1 to biham 20 by 3 plus R2 to biham 10 by 3. So if you solve this, you have 30 by 3, so which is 10 centimeter. Okay, so we are just proving again na. Okay, simple application. Let's solve one question based on this one. Medical exam na. Suppose you have 10 kg and 20 kg. Okay, so 10 kg to 20 kg 20 kg. Separation should be ham. So the rod of they are placed at the length of rod. Okay, rod na ki ka hai. He rod to negligible mass ki so rod in mass na na. Length should be ham 10 meter. Okay, 10 meter rod is here. Distance of center of mass from 10 kg ti chila hai. Chipahi M1 na here lachun, chipahi M2 tiuta na. Kutile center of mass, let's say somewhere here. Okay, center of mass is here. So then this one will be R1, this one will be R2. Kutile question from 10 kg ti alachun pido ha R1 do chula na chila hi. So that means what is this? R1 is equals to opposite mass. Okay, M2 into R divided by M1 plus M2 na chi. M2 is ham 20 into separation to be ham 10 meter divided by M1 plus M2. So this is how much? 20 into 10 divided by 30 na. 0 0 cancel out. You have 20 divided by 3 meter. Okay, so this is the answer. Okay, next another question. Two particles of mass 1 kg and 2 kg are located at x equals to 0 and x equals to 3. Sila hai x y ka ji le chuna sila hai chi x is x equals to 0 ki chu origin ti ne chu sila hi 1 kg maintain. X equals to 3 ki chu sila hi na. So 3, 0. Hi 0, 0. Chila hi 2 kg mass om cho sipen hi. Kutile question position of their center of mass. Anti cho chila hi. Utang na bole hi chila hi. See, suppose if the center of mass is here, okay? So if this is R1, right? So then the position will be what? R1, 0 chila na chila hi. Question should be R1, 0 cho do. So that means you can find R1, right? Using the formula. See, you can also use that regular formula. So XCOM equals to M1 X1, okay, plus M2 X2 so up to you. So if you remember, two particle system formula so two particle system formula so you don't have to write the coordinates and all those things, okay? Let's say center of mass is here, okay? So COM R1 here. 1 kg pahe M1 la lang 2 kg pahe M2 la leo chun kutel chun center of mass position hi bia R1, 0 hi ngai chuna chala he aji so it is at a distance of R1 from the origin. Okay, kutel R1 chu jat ha R1 is equals to M2 into R divided by M1 plus M2 na je M2 chu bia 2 kg separation chu bia amanika separation chu. So here you have 0, here you have 3, so total is how much? 3, right? So 3 meter. Okay, so into 3 divided by M1 plus M2. So this is 2 into 3 divided by 3. Okay, so you have 2. Okay, position so inside the therefore center of mass will be so R1, 0, right? So which is 2, 0. Okay. Okay, next you have motion of center of mass. Okay, one thing 2024 NEET syllabus has a motion of center of mass by delete so it is removed. So if you are preparing for medical exam, so you can skip it. Okay, if extra knowledge if you want to see, you can use see this one. So so not so much, little, but you know that center of mass in general, okay, x, y, zong, z, zong. So here I can write any displacement is equals to center of mass is equals to, so m1 into r1, okay, plus m2 into r2, plus and so on, divided by m1 plus m2 plus m3 plus and so on na ji. Chilai r hi piha ji. So this is position, okay, position, or you can say displacement, okay, displacement, right? Displacement of center of mass so here r can be x, y, or z, okay, so formula is na. So here see, when the center of mass starts moving, okay, it is going to have maybe acceleration, maybe velocity, right? Kudele tang position na kipi alachun, displacement na kipi alachun, velocity chutin holdio ha. So it will be, so drcom divided by dt. Differentiate bol ngai chula na chila hi. So if you differentiate displacement, you're going to get velocity, okay? So if you differentiate this one, you have m1, m2, denominator constant. So I have m1 into, so dr1 divided by dt, okay, plus m2 into, so dr2 divided by dt, so plus and so on divided by m1 plus m2 plus and so on na. Kutila dr by dt to velocity chula na. So therefore vcom so will be equals to m1 v1 plus m2 v2 plus and so on divided by m1 plus m2 plus and so on, okay. Chi velocity na. Similarly, acceleration holding wala chun velocity chu pinabol ha, differentiate na bolong na. So here if you differentiate this, okay, so dvcom so divided by dt. If you differentiate the velocity, so m1 into dv1 divided by dt, okay, plus m2 into, so dv2 divided by dt and so on, okay. So by m1 plus m2 plus and so on. Chizat ni ha. dv by dt to acceleration chula na. So here you have acceleration of center of mass equals to m1 into a1 plus m2 into a2, okay, plus and so on divided by m1 plus m2 plus and so on, okay. Now acceleration of center of mass is a velocity of center of mass is a upon displacement of center of mass na. Okay, so he will have some questions based on this one. So suppose example body khat okay, body body chung I force na. So let's say one force is acting along the side, say 10 Newton, okay, so at an angle 37. So there is another force which is acting directly downwards, okay, so let's say this is 20 Newton, and there is another force which is acting along the side at an angle is that 30 Newton, 30 Newton at an angle 53 Newton, 53, okay. Kutile question 2, what is the force of malachun acceleration of ngai chula na chila here. So what is the acceleration of center of mass, okay, that is the question. Acceleration of center of mass of the system. So what is the acceleration of center of mass of the system? Chilaya batang mass ni le thum kine yona he choice system ki system of particles ni le thum khum na. Atile chilai question he velachun force he velachun. So it is neither along x nor y. So there you have to take component here na. So chilai force he velachun. So here 10 pi 10 Newton pi here. So along the side I have 10 into cos 37 to 4 by 5, okay, which is 8 Newton, okay. Vertical nga component kala lachun. So sin 37 na 10 into sin 37 so 3 by 5, so which is 6 Newton, okay. Abana 30 pa jang split lechun achung langa hojat ha. So 30 into cos 53 to 3 by 5 na, so which is 63 or 18 Newton, okay. Abana cho y langa cho x langa cho 30 into sin 53 to 4 by 5, so which is 64 or 24 Newton. Okay, 5, 6 are 30, 6, 4, 24 na. Atil to he force of say x lang asong uma, y lang asong umta na. So you have all the forces along the x and the y. Two in component jilasun. So what is fx? Fx equals to max ito. Sila na sila here. Along x aso pm, so 8 uma na. So 24 uma. Okay, you have any other? So no other na. So I will have here plus 8 plus minus 24 should be equals to mass kapi nga chala mass, let's say 5 kg, okay. So this will be 5 kg into acceleration along the x-axis. Okay. Kutila chiza diham. So 8 minus 24 so minus 16 is equals to 5 into ax. Okay. Value nom nading in chalahi mass 2 kg lao to chalahi. So 2 kg. So here I will have here equals to 2a. So this is 2ax. So therefore, what is ax? Ax is equals to minus 8 meter per second square. Okay, so acceleration along the x-axis. Similarly, along the y. Okay, so m a y. ppm force to force is equals to 18 uma na. So 6 uma chung ako. So 18 plus 6. So plus minus 20 should be equals to 2 into ay. Okay. Is that the answer? So 24 minus 20 should be equals to 2 into ay. Chichu 4 is equals to 2 into ay, or acceleration along the y component will be 2 meter per second square. Okay. Butang hichi vilauchun hichi center of mass to iti relate ha. So the reason why we are doing this, it's like Newton's second law is like wachana. So whenever we write F equals to ma, okay. So whenever you write F equals to ma, so here A is the center of mass, okay, acceleration of center of mass, right? Hichi hila momentum is na. So when you write momentum, so you know momentum is m into v, okay. So like v pa he pm, v pa he velocity of center of mass, okay. Na chila he chi piha x component of acceleration of center of mass. Okay. Ye y pa he piam x y component of acceleration of center of mass. So therefore, what is the net acceleration? A net will be equals to ax I cap, okay, plus ay z cap. Acceleration ax com. Okay, so you can also write like this: ax com, ay com. Na. So ax com plus ay com. Okay. Azola nga r com zita pang wasana r com sa piha x com I cap plus y com z cap plus z com k cap sila na. So similarly, you can write acceleration equals to tang acceleration vector sa piha ax com I cap plus ay com z cap. Na chuchusan ham. So minus 8 I cap plus 2 z cap. Okay. So this is the acceleration. Okay. Just revision. Displacement of center of mass to here. So velocity to you have this one, and then acceleration is this. Okay. So if you differentiate x, you'll get v. If you differentiate v, you'll get a. Okay. So we'll solve 1 or 2 questions. I think we have 2 questions. Masapahi, consider a system of 2 particles. Particle you maintain. So here I have 1 particle. Another particle is here. Okay, one of the particle is at rest. So let's say this is at rest. Okay, another other has an acceleration of a. So chipa an acceleration. So it has acceleration a. So the center of mass has an acceleration of how many? Katpasu ipiha a is equals to 0. Na chipa he. Katpasu a na icho asala he. So then what is the a net? A net ipiha. Chila identical particle kiti chula na. Chipa he m here chun. Chipa zong he m. Okay. So XCACOM sa piha. So this is M1 A1 plus M2 A2 divided by M1 plus M2 na chihi. Kutila mass ke ba azia chum M into mass pa 0 na. First one is at rest plus M into second is going with A. Okay, divided by M plus M. So how much is this? M into A divided by 2M. So MM gets cancelled out. So this is A by 2. Okay. So A by 2. But now last question. 2 blocks of 10 kg is placed on the x-axis. If first mass move by distance of so this move by 2 centimeter. Okay. But before this, I'll give you one thing. Suppose I have mass M1 here. Okay. So another mass M2 here, right? Kutile. So here, let's say the separation is say R. Na here. So here, see, if I displace, okay, if I displace M1 by some distance, let's say this is x tiu na jepen x aka hian phaya la chun hi chi m2 pa jong hena center of mass is 0 am na dinga so let's say the center of mass is not moving okay center of mass is at rest okay for the center of mass to be at rest hi chi m2 pa hena so by how much I have to move so that is the question aji chu batang hilai m1 or hilai m2 center of mass is hilai tiu na example so if I shift the position of m1 here so the position of center of mass will also try to shift see the point is if the position of m1 changes x1 jong ke khial chu na chila hi x1 y1 jong ke khial the ja chu center of mass jong ke khial le chu chila hi so if you move one of the mass the center of mass is going to move chila question chu pham center of mass is cha long na dinga chu na if this is moved by some distance so by how much you have to move m2 so that the center of mass does not change okay khutile formula so direct in apply le chun xcom chu pham m1 x1 plus m2 x2 okay so divided by m1 plus m2 so here if I differentiate okay so dx com divided by dt this is equals to m1 into so dx1 by dt plus m2 into so dx2 by dt okay or in general na mass thum jang na habe thile so m1 plus m2 atile chala hebele chun see in all these terms there is dt common okay dt common pahila do chun so I will have here dx com divided by dt should be equals to 1 by dt into m1 into d1 dx1 plus m2 into dx2 okay divided by m1 plus m2 okay atila chala hi dt gets cancelled out okay question chila hum ki do ala chuna so most of the time you'll have only two system okay atila chun chala ta dx com chu ha so this is equals to m1 into dx1 plus m2 into dx2 divided by m1 plus m2 na chepi de na ha m1 pa hai na if it move by dx okay m2 pa if it move by dx2 then the center of mass will be shifted by dx okay so dx ki jo pa change dine so japan so change this are the change right kutil che pa hi in apply jo so like formula hai che question hai atila chila hi 10 kg jong mana so you have 10 kg and then you have 20 kg okay are placed on the x axis right so if the first is moved se pa hi m1 tiu na se pa hi m1 se pa hi m2 khutile 10 kg pa hi 2 cm a cha la chun so let's say therefore you have dx1 is how much 2 cm okay khutile dx2 chu is a cha la chun dx com jana center of mass pa chu chang laude so will be unchanged no change okay so dx com is 0 so if dx1 so if the m1 moved by 2 cm so by how much the m2 should move so that the center of mass is not changing okay is at rest formula se apply on so dx com chu piham so m into dx1 plus m into dx2 divided by m1 plus m2 na chala hi khotela chun chi change in center of mass 0 ke pi chula na chala hi mass m1 chu 10 pa chu 2 cm a chang na so 20 pa chu ki hello cho dx2 divided by 10 plus 20 okay so what that means how much is this 30 pa here value transformation 0 na so I will have here 0 equals to so 20 plus 20 into dx2 so or I can write 20 into dx2 should be equals to minus 20 okay 20 gets cancelled out dx is minus 1 okay minus 1 should be opposite side of displacement okay so here you see 10 kg by 2 centimeters so let's say it is going towards the right by 2 centimeter okay so therefore center of mass so raise am na 20 kg by velanga 1 centimeter amki hial ngai cho amki shift ngai na okay so that is the answer right so by what distance should the second mass be moved to keep the position of center of mass at rest right unchanged so it has to move minus 1 that means towards the opposite of this okay by 1 centimeter okay concept pa jo I bolo ta yana so after hichi question hoina available bolket vilang
So try to understand all these questions. Okay. Chizo pala chun. So you go to your take one book na. So any book, okay, for JEE or NEET na kapempilawe lang. It's like question also bon and solve lesson. Okay. So you'll find all this PDF in the Telegram channel. So I have put the link in the description. Okay. Right. We'll do this much. I hope you understand. Center of mass, I think we have done everything. Okay. What is required? Okay, we'll stop here. I hope you understand. Thank you for watching.